morning, everybody. Thank you for coming out on such a miserable morning. Hopefully, I'll brighten it up a little. Oh, that was lame. But anyways, really, thank you for coming out on a rainy, cool, wintry morning. Luckily, it's not ice. It's quiet. All right. Let's get back to chemistry. And yesterday, I was talking about the chemical symbol. I'll never ask you how to define a chemical symbol, which is a chemical symbol is one or two letter abbreviation for names of the elements. And I'll teach you later on this morning what is an element. And the first letter of an element is always capitalized. The second one is lowercase. Now over here, which a lot of you can't see, is a periodic table, which I'll teach you about, and it lists all the elements. And if we go to a nicer one here, you'll see there are a lot of elements. And this periodic table goes up to 118 elements. Now, as I mentioned on Wednesday, I have worked in the real world, still do. I consult, and I teach in the real world, and I live in the real world. And most of these I have never used, and you will never use. So therefore, for me to have you memorize all the names and symbols on the periodic table is a tremendous waste of time. There are key ones I do want you to memorize, and let's look at those. And here's my Friday morning gift to you. I'm only asking you to learn 37 of the 118. But these are elements you and I both use in our daily life. And what I mean by memorize is, on a test, I could ask the following. By the way, see me in private. I mix both print and handwritten. By the way, if I ever write something on the board and you have no idea what it is, raise your hand and ask, what the heck is that? Or some other suitable way of asking me to print it better. But anyways, on a test, if I had sometime in the future and something I pass out in the class, all tests are on Fridays, and that gives me time to grade them over the weekend because I rarely use multiple choice. Therefore, my test will take, for this class, about 3 to 5 hours to grade, but you're worth it. But anyways, when I ask what's the symbol or what's the chemical symbol for an A carbon, well, hopefully you've learned carbon is C. And if I ask for bromine, bromine is Br. Oh, I know them. I should. But anyways, here are the key ones. O is oxygen. H is an important one, hydrogen. How many of you have heard your doctor saying, mine has told me, keep your sodium content down in your food, and A is sodium. One I just found out about a couple of months ago, and I said you'll learn a lot about me. I was having problems with my feet and also muscle cramps. And my podiatrist told me, well, get more potassium. Well, I don't like bananas, no thank you. But I looked online, and sure enough, they had potassium citrate supplement. And lo and behold, I took some potassium citrate, which potassium is K, and it's helped my muscle problems and feet, which is a good thing. Now, this is one type of problem I can ask on a test. Another is, would be same thing. can I get asked on a test, what is the name of the chemical symbol of the element with the chemical symbol Li? And if you notice that, up there is one you need to know, that's lithium. And then I have another one, Au, and Au is, we're in the high price district now, is gold. And this is what I mean by you should learn both the symbol and the name for each of these. By the way, Kr is krypton, and unless I was hijacked to another universe in our world, krypton is not a green solid that kills Superman, but a colorless gas at room temperature. For those who know Superman and the legend of Superman. Hopefully I just didn't do a generation gap. But anyways, how do you memorize those? We can use flashcards, but for me flashcards never work. How many still can remember, you don't have to raise your hand, sure not, what I wrote here on Wednesday? Can you see it? Can you see the color of the ink I used? Well, by repetition helps you learn these. And what I mean by repetition is, if I, on a piece of paper, at home or wherever you study, if you were put down the following, and then write silver, and then do it again, and do it 5 times, Ag, silver, Ag, silver, Ag, silver, guess what? It gets burned in your brain. A couple days later, you do it a couple more times, and you've got it memorized. And it works quite well for most people. Whatever works for you, do it. But this is something I would hope you all memorize. If you don't, you're going to lose a lot of points on test 1. You're going to have trouble with test 2, 3, and 4, and the final. So this is an important thing to learn. All right, important pro tip from Dr. White. You will not learn chemistry a day or 2 before the test and do well on the test. Trust me, I was a chem major, I'm still a chemist, and I didn't learn chemistry a day or 2 before a test. I studied a lot. No chem majors do that. And but start now. Start practicing these and learning these. You've got plenty of time before test 1, and this will help you do good on the test. Oh, that reminds me. I haven't seen it in a while, and now I'm really going to do a generation gap. But for a number of years when I was driving around the area here, I run into this one car, had a vanity plate, and his vanity plate was I pulled up the first time behind that car, looked at it. I have a vanity plate too. In fact, I was one of the first in the state of Illinois to get one because I was working in politics then. But anyways, I look at that, and it took me about 2 seconds to realize it, and I started laughing and said, this guy's cool. And that is Hi-Ho Silver. For those of you who know the Lone Ranger, I think I just did a generation. When I was a kid, the coolest thing on TV was the Lone Ranger. And not the last movie, they ruined that. The last movie with Johnny Depp, I think, was awful. I just saw the trailer, I couldn't see it. Go look online and look at Clayton Moore, Lone Ranger. But anyways, you should learn these. Now, when we're talking about studying chemistry, the important thing is we're studying matter. And I discussed what matter is, but matter can exist in different states. And that means physical states. And by the way, Dr. White can be very subtle. All right, the first state of matter is a solid. I think a lot of these you're familiar with, I hope, but if not, I'll go through it. And a solid is something that has definite shape and definite volume. You should know the definition too. Big hint. And therefore, if I look at this tabletop, it's a solid. How do I know that? It's got definite shape and definite volume. The shape, it's going to be like this. If I come back in an hour, it will be like this unless somebody takes a sledgehammer to it. And the volume is the measurement, height, width, and length. And that's a solid. If I look at my ring here, it is a solid. It's made of gold too, and I better not you know. Anyways, it's gold and it's got definite shape, and I can measure the volume. In fact, in one of the labs, you'll be measuring volume of solids and other physical states of matter. Now, the next one is a liquid. A liquid has something called indefinite shape. What's that? Well, indefinite shape means the material or matter you're looking at takes on the shape of the container. What does that mean? Well, let's get real world, because that's where it matters. Notice in this bottle, I have a material. It's called water. I think you're all familiar with it. I hope. If not, you'll learn more about it. And notice it's taking the shape of the bottle. If I were to take the water out here and pour it into glass that's a cylinder, warning, art from Dr. White, big warning. I'll never go to art school. By the way, you are totally permitted to snicker and laugh at all my artwork. And if I put a glass like that, cylinder glass, you can laugh, it's permitted. And I pour the water in there, it won't have the shape of this bottle, it'll take on the shape of a glass. Now, I've only seen once in a catalog long ago, and I should have bought it, and I didn't. Somebody was selling glasses that were square. And I thought that was cool, but I didn't buy it. I haven't looked again, but it's not a big thing on my to-buy list. But if I took the water from that glass, which is a cylinder, and poured it into the glass that was a square, the water would take on the shape of the glass. And that's what we mean by indefinite shape. But it has a definite volume. The amount of water in this bottle, I can measure the volume. We'll be doing that in the lab. And when it was full, you look at the label, it said 23.7 fluid ounces or 700 milliliters, which is a measure of volume. And this has volume. If I pour it in another container and pour it all in, it will still have the same volume. And so a liquid has indefinite shape and definite volume. And the last state of matter is gas. And if you haven't thought about it, right now you're surrounded by gas, and we call that air. And air is a gas. How do we know it has indefinite shape? That means if I had a sample of gas, whatever container I put it in will take the shape of the container. In this case, it's taking the shape of the room. And it also has indefinite volume. If I had a small amount of gas in a cylinder here and opened it up, it would spread throughout the whole room. If I had, I don't know, what would be an example? Here's one, you won't like. But if I had, it's called a thiol, which is a very stinky compound. They put it in natural gas so you can smell it if you have a leak. If I had a small amount of thiol and I opened a container here, everybody in this room, after a little while, because it would spread out, it has indefinite volume, would smell it and would stink. Let's go with something else. If I had essence of a rose, and it's a volatile compound, if it was in a gas, and I opened up the container, you'd all, I smell a rose. And therefore, a gas fills up the container it's in, so it has indefinite volume. So we have a solid that has definite shape, definite volume, a liquid that has indefinite shape and definite volume, and finally a gas that has indefinite shape and indefinite volume. Now, one of the things I like to do to make Dr. White feel good, and that's a good thing, is I like class participation. And that's where we all get together and say, class, what are the 3 different states of matter? The first one is, everybody, come on, solid. All right. It's the first week of class. You should be fired up. Everybody together in one group. First state of matter.
Solid.
Thank you. Second one.
Liquid.
Third one.
Gas.
Excellent. And you should know that a solid has definite shape, definite volume. A liquid has indefinite shape and definite volume, and a gas has indefinite shape and indefinite volume. And the next time you have a friend who burps while you're around them, you can say, you know, you just burped something that's a gas and it has indefinite shape and indefinite volume. Don't do that. You'll lose a friend very quickly. But next time you drive by a gas station, think about the fact that they're selling gasoline, and that's a liquid. And chemistry is all around you. By the way, when you walk out that door or back door, you can still think about chemistry because it's all around you. I stole that from SpongeBob. Anyways, it's all around you, and it won't hurt to think about it. Trust me, I'm a chemist. Does that work? So anyways, you should know. And notice I'm being very subtle, because on a test, I could ask the following question. In a box, there's a material that has this volume, but it has indefinite shape. Is it what state of matter is it? And the answer would be gas, or no, liquid. Even I make a mistake once in a while, I was here. And if I ask, give an example of a solid in your daily life, there are a lot of them, I guess one that would come to mind real quick, an ice cube. An ice cube is a form of water that's a solid. And it has definite shape and definite volume until it melts and becomes a liquid. So you should know that the three states, let's do it once more, it's fun. Everybody together, first state of matter is
solid.
Thank you. Next one.
Liquid.
And the last one.
Gas.
And you should know that a solid has definite shape, definite volume. A liquid has indefinite shape, definite volume, and a gas has indefinite shape and indefinite volume. And that's why if you think about it, if you have a gas leak in your house, it's very dangerous because the gas has indefinite volume. It will spread throughout. The one thing you don't know, but I do because I work with hydrogen, which is very explosive in the chemical plants. If you have a light switch like this, when I do this and turn on that light, there was a spark in there. If there was gas in this room, which would also be in there, it would have blown up. And that's why it's important to be able to smell when you have a gas leak. All right. Now, when we talk about matter, there are two types of matter. The first type is a pure substance, and the other type are mixtures. You use both in your daily life. Not to scare you, but you do. And let's talk about that. What's a pure substance? What's a mixture? By the way, remember, I have the fastest mouse wheel this side and the other side of the Mississippi River. So if I want to move too quickly through a slide, let me know, I can back up. Also, just remember, anything I put on the screen, except my hand, which I'll take off the screen, that was an awful one, I'll never use again. Anything on the screen here is on Blackboard for you to download at your convenience. And if you're having trouble with Blackboard, logging in or downloading, call the helpline here. The people in the IT group and the helpline are very helpful at the school. You don't know that yet. Now, what's a pure substance? A pure substance is a type of matter that has a definite or fixed composition. That means if it's pure, it's always that certain composition. Another way of saying that is it's composed of one type of atoms or molecules. Now at this point you may not know what an atom or molecule is, but relax, I'll be teaching you that. But this is a definition of what a pure substance is. Now, I'll never ask on a test what's a pure substance. Well, I expect you to understand it, and I could ask, can you give an example of a pure substance, and we'll get into that. One of the things I did about 1.5 years ago, I came to the conclusion on my test, especially in general chemistry like this, am I testing your knowledge of chemistry or am I testing your knowledge or ability to memorize things? And I felt it was more important to test your knowledge a chemistry to memorizing. So yes, there's some memorization, but you'll see later on in the coming weeks, I've cut down dramatically the amount of memorization you have to do. I think that's a good thing. You're still going to learn chemistry. Now, when we talk about pure substances, there are two types. One is called the elements, and the other is called compounds. So there are two types of pure substances. And a pure substance is something that's made up of a fixed composition of something or the same type of atoms or molecules. So when we look at this, what's an element? What's a compound? Let's find out. I'll never ask on a test definition, but I'll use the term, so I wanted to define it now. What is an element? By the way, when I say I'll never use on a test, people in the front have everybody behind you is looking as I said that. An element is a pure substance that contains only one type of atom. And I'll teach you later on what is an atom, but it's also a pure substance that cannot be broken down into simpler substances by chemical or physical means. And as I pointed out earlier, my ring is made of gold, and gold is an element which is a pure substance made up of one type of atom. The ring part, not this part, is all made up of gold atoms. And if you have something made of silver, that's a pure element. Another pure element would be sodium metal. I'll teach you about that later on. It's cool stuff to play with. Dangerous, but cool. And those are all pure elements. And when it comes to gold, or if I had iron, or if I had, what would be another example of pure? Argon. I've used argon in gas, AR. You can't break it down to something smaller. I'll teach you for compounds, you can't. So we have an element, and you can't break it down by any means to anything smaller substance. And it consists of one type of atom. And here we have, and I'll show you over here in case you can't see it, all the different elements. And these are all exist as atoms when you talk about them as an element. Interesting one, mercury, Hg. I think you've all seen mercury metal, like we had on the video you saw this week in lab. And it's a liquid at room temperature, very heavy liquid. That's also extremely poisonous, which is in thermometers. And a lot of people now are using digital thermometers. And it's a liquid at room temperature. Now, when I was a kid, they had a thing that was like a little maze with a big drop of mercury. You could go like this and move it through the maze. And the back was a piece of cardboard. And thinking back at that, how could they give this to kids? Because that mercury, if somebody ripped off the bottom or ripped, and now you're exposed to mercury, that's a poison. Bad thing about mercury, it's a cumulative poison. Once you get it in your body, you can't get it out. And with time, it builds up till it does damage if you're exposed enough. And in our society, we've cut back on that. Well, if we look at, let's go back real quick here. Other ones, potassium, magnesium is interesting. Now, calcium exists in different ways, but calcium as an atom is a metal. Now, how many of you heard you should get calcium to have strong bones? I think you've heard that. They're not talking about calcium element, because calcium element is like this pipe, assuming it's metal, or my ring. I don't think you want to be chewing on this to get your calcium. And I'll teach you later in the semester the other type of calcium that does give you strong bones and helps your body. But first, it's time for a commercial from Dr. White. And don't forget the chemical symbols you should start learning. There are one or two a letter abbreviation. The first one is always capital. Second is lowercase. Again, this is a commercial from Dr. White to help you do good in this class. And you should learn these elements, and we've gone through that before. And you should know, like He is helium, Ni is nickel, Cu is copper, Ag is silver, some others, N is nitrogen, Ne is helium. How many of you have ever seen the balloons for parties that float? Or if you've ever seen someone take some helium in and they talk like a cartoon character? And helium has the chemical symbol Ag. And neon, argon, and so on. So you should know these, and that's my commercial. Now, there are two types of pure substances. One is an element, the other is a compound. I'll never ask you what's the definition of a compound, but you should know examples. And a compound is a pure substance that exists, that consists of a combination of two or more elements, always in the same ratio. Another way of saying it is, it's a pure substance that can be broken down to two or more simple substances by chemical means. And let's take a look at that. I'll teach you later on what I'm going to do on the board, but I think a lot of you might be familiar, and that's writing using chemical symbols that show a compound, also called a molecule. That's in my bottle, and that's water. And I'll teach you later on that means 2 hydrogens, 1 oxygen, but this is the composition of the material in this bottle. I bet you never thought of water as a chemical, but it is. It's chemistry. And water is not an element because it consists of more than 1 atom. 2 hydrogens, 1 oxygen. And I can break down water electrically, don't try it at home because it's dangerous with electricity, to make hydrogen and oxygen. Now another one you're probably familiar with, because it's keeping you alive right now, is oxygen gas. Oxygen gas has 2 atoms of oxygen. I can break that down, and that's also a compound. Another one you're breathing right now, it's getting serious, is nitrogen gas. And this nitrogen, the 2 means there are 2 nitrogen atoms combined together to make what you're breathing right now. The air you're breathing consists of 80% nitrogen, 20% oxygen. And that keeps us alive, which is a good thing. At least I think so. And there are many other pure substances. Oh, here's one. You take 1 sodium atom and 1 chlorine atom, combine it together, you get a molecule called sodium chloride. You know it as table salt. You put it on your French fries, as I do, or put it in your food to season it, and that is a compound. It's made up of more than 1 type of element. It has more than one atom, and it has 1 sodium and 1 chlorine. Hopefully you'll learn Na is sodium and Cl is chlorine soon. Now, true story. If you ever go out to lunch, breakfast, or dinner with a bunch of chemists, and I'm going to have to admit I've been guilty of this many times when I've gone out with colleagues, one of us will invariably say to someone else if we're at a restaurant, "Can you please pass the knuckle?" Knuckle? Never mind. Oh, by the way, it's permitted to groan at bad jokes. So there are many compounds in our daily life we use. I'll give you an example. The soap you use to wash your hands, that's a compound. If you use mouthwash, well, that's a mixture, I'm getting at. But the soap you use to wash your hand is a compound. And you should know examples of those. Now, the other type of substance is called a mixture. And a mixture is two or more substances that are physically but not chemically combined. I will never ask on a test what's a mixture, but I can ask, give an example of a mixture you use in your daily life, and let's talk about those. Again, a mixture is where you have two different substances that are physically combined but are not chemically combined to form a new substance. Let's see, do I have an example? No. Before I do that, let's do a real quick mind experiment. I have water in the bottle. If I had some salt and I mixed it, put it in here and shook it up, I would now have a mixture of salt and water, salty water, and I don't think I want to drink it, but, well, I could put sugar. Sugar is a compound, and if I mixed it with the water and mixed it up, that I drink because it'd be sweet, not salty. And those are both examples of mixtures. Now, what you don't know, but I'll teach you now, is gasoline that you buy is a very complex mixture of different things. Things that make your engine run, other chemicals in the gasoline that are pure substances that help clean parts of your engine and make your engine run smoother. Time for a what they call a public service announcement from Dr. White. One of the companies I worked for where I was the R&D manager, I helped sell certain additives to the gasoline or petroleum companies like Shell, Mobil, BP. I got to work with those companies to know about the gas industry, gasoline industry. And people in the industry, and I learned from them, the best gasoline is Shell. By far, it's always been for decades now the top quality. Mobil is almost as good as Shell. The worst one, which I will never put in my car, is BP, used to be known as Standard. And it's been bad for decades. Back in the 80s it was bad. And how bad can bad be? Well, a couple of years ago in northern Indiana and Illinois, right near Hammond and Gary, that part across the border, BP sold some gasoline, made and sold some gasoline that was so bad it destroyed the car engines of about 3,000 cars. You can look this up on the newspaper or online. Go ahead and check it out in Google. If they can't do that kind of quality control and sell a good product, I'm not going to buy it. And so the best gasoline, Shell, Mobil is quite good. Now, Marathon, I don't know who they buy from, Shell or Mobil, but it's quite a good gas too. I think I covered all the main people who sell gas, but don't put BP in there. Not that I have anything against BP as a company, but their products have never been good. Now, when we talk about mixtures, hold on one second. Friday. And when we talk about mixtures, there's two types. One is homogeneous, the other is heterogeneous. And what is a homogeneous mixture? A homogeneous mixture is a composition, it's a mixture made up of more than one substance that is uniform throughout the sample. And later in the semester, I'll teach you that's also called many times a solution if it's a liquid, and be a solid too. Homogeneous. What do I mean by that? If I were to take my water bottle again, and if I were to put in salt or sugar and mix it real good, it'll look like this. It'll be the same throughout. and that's called a homogeneous mixture. So what would be an example on a test? I'm never going to ask you what is a homogeneous mixture, but I'll ask you to give an example of a homogeneous, and you could have just said sugar and water. Now another one you probably won't think of, but I'm a chemist so I do, and that's right now you're sitting in a homogeneous mixture. It's a mixture of, somebody was nice enough to write on the board, oxygen and nitrogen gases, both substances. And if I stand here, I'm getting the right amount of oxygen to keep me alive. And if I stand over here, I'm not going to go, I can't breathe, there's no oxygen here. No, it's the same. It's a homogeneous mixture. So next time you're at a party, if you like the Super Bowl party a week or so from now, and you want to impress people, say, you know you're standing in a homogeneous mixture, don't, you'll be asked to leave. Don't talk chemistry at Super Bowl parties. Anyways, homogeneous is same throughout. Gasoline is a homogeneous mixture. It's the same throughout. When you put it in your car, you don't want different things coming in, not the same amounts. You want it to be the same throughout what you put in your gas tank. Now, the other type of mixture is a heterogeneous mixture. And heterogeneous means it's not uniform. Just like you've heard the term homo and hetero, homo the same, hetero different, and you can apply those prefixes, whoa, using fancy English words now, to different things. But in chemistry, a heterogeneous mixture means it's a composition that is not uniform throughout. So let me pick on my water bottle again. And if I were to take this water bottle, which I won't, but if I did, and I had a handful of sand, silicon dioxide is a pure substance. And water in this bottle, hopefully, is a pure substance. And if I were to pour the sand in here, what would happen? It'd go to the bottom. If I shook it up real good and then placed it down like this, guess what the sand is going to do? Float to the bottom. Therefore, it won't have the same amount of sand up here that's down here. Therefore, I'd say that's a heterogeneous mixture. How many of you are familiar with the oil vinaigrette dressing? You can get it at your local supermarket. And if you pick up the bottle from the either shelf from the supermarket or if you have it in your home, and usually if it's open in your refrigerator, you'll see 2 layers. I'm not going to impress you with my bad artwork and try and do a bottle. And you'll see 2 layers of material right here. And this one is the oil, and this one is the water, or vinegar. Vinegar, I'll teach later, is mainly water. And if you shake up that oil vinaigrette dressing, you put it in your salad, and then if you put the bottle down and come back about 5-10 minutes later, what happens? You see 2 layers. And that's an example of a heterogeneous mixture. So next time you're having dinner with someone, they have the oil vinaigrette dressing up, oh look, a heterogeneous mixture. No, people don't like hearing chemistry at dinner. And these are things you should think about in your daily life as you go around. Is that a homogeneous or a heterogeneous mixture? Or is it a pure substance or what? Now, when we talk about matter, matter has various properties. And these, and I'll never ask you this definition I'm giving you now, but I want to tell you this because I'm going to talk about it so you understand what I'm talking about. And what we talk about properties of matter, these are characteristics that distinguish one substance from another. How do you know the difference that this is gold and that's water? Well, it has different properties. And when we talk about different properties, same thing. How do you know we're in air right now and this is water? Because it has different properties that you can observe and measure. The first type of property is called the physical property. And a physical property, and I'll never ask you on a test, what is a physical property? Again, I'm cutting down memorization. What you need to know, in case I'll ask you, I'll talk about the other type of question again, are characteristics of a substance that can be observed without changing the basic identity of the substance. Another way of saying that is they are distinguishing characteristics of a substance that can be used in its identification description. So what would be an example of a physical property? Well, look at my shirt. It's blue. The color of something is a physical property. You can look at my shirt and identify what color it is without destroying the shirt, or more importantly, without destroying me. And that's a physical property. Another one, if I asked you, not today because it's awful outside, but if I said, why don't you, when you go out in the parking lot and walk down the road, count how many blue cars there are. Well, let's go to a different color. Red cars. And you can count the red cars. Are you going to destroy the cars by counting which are red? No. It's a physical property. Another physical property when we talk about chemicals or substances like water, what's the temperature this boils at? It's called the boiling point. Hopefully you've all seen boiling water, you know, when you heat it up and you see the bubbles come out from it. And I'll teach you about that later in the semester. The other thing is, I think most of you have experience putting water in a tray in a freezer to make ice cubes, and you're freezing the ice, and what temperature does that freezer melt at? 32 degrees Fahrenheit or 0 degrees Celsius, and that's a physical property. I can measure that, and I will not change that this is still water. If I put this bottle in my freezer and it freezes, and I measure the temperature, which it froze, I still, when it thaws out, by the way, it's a change of state of matter, I'll talk about today or next week, it's still water. So these are physical properties, are things you can measure, observe, without changing what is the material. Now, there's another type of property called a chemical property. And a chemical property, no, this is chemistry. Chemical property is a characteristic of a substance that describes the ability of a substance to change into new substances. So a chemical property describes how something can change into something else, or maybe not change. Now, let's talk about a important physical property of water, or chemical property, excuse me. Water does not burn. I can use this to put out a fire. Do not try this at home, but gasoline, we call that flammable because it will burn. If I had, did the sign-in sheet make it around to everybody? Thank you. If you came in late, it'll be up here. Don't ever try this at home, but if I had a match or a lighter and I go like this, a chemical property of paper is it will burn. By the way, most organic chemists when they were young were secret pyromaniacs, like to burn things so much. But anyways, I was an organic chemist when I was young even. I like to burn things. And that's a chemical property of paper, that it is combustible. And there are other chemical characteristics or properties. Example, steel, iron will rust. If you look at two cars, and if one's made of regular steel, it could rust with time. Now, I might do a generation. How many of you ever saw Back to the Future movie? The car they used is DeLorean. And when DeLoreans came out, there were only a few made they didn't catch on because they're expensive. They were made of a substance called stainless steel. which is much more expensive than the steel you have on your car. Why? Because it won't rust, and that's a chemical property. Stainless steel won't rust. Rust is forming what we call ferric oxide, you know, that other stuff that falls apart. Your car rusts out. Now another one, I've talked about flammability, toxicity. If you were to take sodium chloride and taste it, you'll be all right. Do not try this at home ever. But certain substances are poisons, and those are toxic, and if you take them, you'll die. Don't take them, please. And that's also a chemical property as opposed to physical property. So on a test, if I were to ask, give an example, wow, time flies when you're having fun with chemistry. Give an example of a chemical property of a substance. You can say iron rust. You can say gasoline or paper is flammable. Those would all be examples. And I would ask you this weekend, when you have a chance, look around this stuff and think about the chemical and physical properties. This is red. Physical property. If I take this and put a heat source on it, like a hot metal, it will melt, and that's a chemical property. Now, the fun part of chemistry is making things change. And my training has been in what I'm a synthetic organic chemist. Synthetic is a fancy word meaning to make. And my training is to make things, and you do that by making changes in chemicals. And that's the fun part. What some of the chemicals I created, new fabric softener, new glue for holding sand together to make molds and car engines. Those are some of the new things I've worked on. And when we talk about changes in matter, there are two types of changes. One is a physical change, and the other is a chemical change. Just like physical property and chemical property, when you change things, you can either change it physically or you can change it chemically. Now, a physical change, and I'll never ask on a test, what is a physical change, but I will ask examples, is a process in which a substance changes its physical appearance, but not its chemical composition. And usually that involves a change of state of matter, going from a solid to liquid to gas, or vice versa. So an example of a physical change is water melting. If you have ice, it's a solid. When it melts, it becomes a liquid. Guess what? It's still water. And that would be a, well, I've got 20 seconds left, I better use it. That would be a physical change. Another one, which I don't like to use, but I'll use it anyway, I won't do it, but if I were to rip this in half, it's no longer the same piece of paper, it's different, but it's still paper. Paper is a chemical too. And that would be a physical change. And with that, I think I'm out of time. Oh my gosh, I went 7 seconds over. I'm sorry. Everybody, have a great weekend. You went away.